Google Colab, we can find it from Colab, which is colab.research.google.com. And this was the interface that it took us to. And the first thing we did was to create a new notebook. But you notice if you've got other notebook that you can have access to. I've created a previous one for the ice cream one. I'm going to create a new notebook and I'll just call it ice cream 2. Give it time to load. And what I'm going to do differently from what I did last time is just give it a relevant title. So in this case, I'll call it ice cream 2. You call it whichever version you want to call it. I'm calling it that because I already have ice cream 1. And you take note of the extension, because with this extension, you can import your code to Colab. And we said it's good to structure your code, so give it right sessions. So basically just have like a proper documentation for it. And we are going to give our code a title, which is a test. And I'll double click in there. That's not what I wanted to put there. Double click in there and give it a title. So let's say code to perform simple linear regression. And I'll toggle comment and I'll just press shift enter. And again, we want to give it problem statement. So let's write down the statement. We didn't do that last time, but basically get a chance to do it now. So what is our problem statement? And I'll toggle the I'm just moving a bit so it become a bit more clear for you. Hopefully it's more visible now. I'll just be zooming out a bit more slowly. Maybe just one font size later. So I just copied the problem that we had, which was the ice cream problem, and paste it here. It should be a test. So let me put that problem. Paste that there, and I'll press shift enter. So basically what we have is you own an ice cream business and you would like to create a model that could predict the daily revenue in dollars based on the outside air temperature. I can change it to cities or pounds, whichever you prefer. You decide that a linear regression model might be a good candidate to solve this problem. So we've got access to the data set, which the independent variable, or the X, was the temperature, and the dependent variable was the revenue in dollars. So you can just adjust it to suit yourself. So that's where we started from. And what was the first step that we had to do? Anybody remember? The first step we did. What was that?
Importing the libraries.
Step 1 was to import the libraries. If anybody can get all of this correct without having to read, I'll be very happy, and that person deserves a chocolate. We have to find a way to get you that chocolate, right? So we just say step 1. Was import the libraries. And so toggle shift enter. And what were some of the libraries that we used? I've heard pandas, NumPy, the master, pandas for visualization, or CSV, or importing into a CSV. Which others?
Seaborn.
We've got Seaborn, and then we've got Matplot as well. And then there was one more that allowed us to get the absolute path to the file that we are using. What was it?
OS.
That's brilliant. Are we all reading or are we actually saying from memory? Who is saying from memory in the class? I'll let Kwabna fish out who is actually saying it from memory. That person should get some chocolate at that point, not to put Kwabna on the spot. Right. Can I continue from this point?
Yeah.
That's brilliant. And then, so after we imported the libraries, what was the next step? What was our step 2?
Importing the data set.
Get the data set. That's it. So step number 2, import the data set. Shift enter and make sure I toggle this. It looks a lot cleaner. So I know where my data set is sitting. Your folder will be different, or you may have named it different, but later on when we give the absolute path, you can find from your Google Drive. But so basically, I want to go from Google Colab, and from there, I want to import a drive. So at least I can go to the drive and mount the drive, right? So I get into that drive, and then I can mount it. Oops. Times it's a lot quicker to type. And to mount it, you find it in terms of the path. To mount, you find it in the contents, and then you find it right. So hopefully it won't scream at us.
Hello.
I give you the chance to mount the drive or to link it with my Google Drive. So I'll click connect. And I'll put this on the side just in case you ask for some password, but basically it's allowed me to give access to it. So I allow and then create a link to it. And hopefully it won't scream at us. It took its time, but at least it's mounted the drive for us.
My goodness, the problem is
What do you do?
Are you happy for me to continue, or do you want me to go up or down? Can I continue?
Oh, you mean the problem statement? Type it. But I also typed it. Like I just typed it.
There's a question about problem state. I just copied it across, put in the chat. I know Quick now has got a link to it, but for now you can it's just describing the whole thing, but you can type yours or leave that part and do it in the end if that helps. It's just like a header for it. So it's a statement at the moment. Yeah. So on that note, are you happy for me to continue? So we can stick to the code. You can just leave the heading and then later fill it in. You will get access to the code anyway. So that's just a bunch of notes. Are you happy for me to continue from this point?
Yeah.
Thank you. So basically, so far we've just done the mount. We've created a link to our Google Drive, and we want to assign the directory. So let's find the directory to our data in terms of the data part. So let's go for data directory. And of course, up to this point, it can serve as a really good template. So the more you type it, the more it becomes like a second nature to you, right? Because all we're doing is assigning or linking our data set, and you go through similar steps each time you run it. So it will find it in our content, flash drive. And on my case, it was in my drive. And I made life simple for myself by putting it in the AI, and then the file was called ice cream. And it was a CSV file, so I can have ice cream.csv. So I'll press Shift enter, and hopefully it won't scream at me. So it's not giving me any error yet. But again, if you want to find out what you have in your dataset folder, it would be good practice to rather have it as a dataset folder that you put all your data sets in. So I can have like use Linux command, the list command. Just want to see what's in there, and I can go into my folder and press Shift Enter, and we notice that it showed me what else is in that particular folder. The ice cream there, so it's the right data set link. So we've created the path to our ice cream, and all we want to do is just assign that to, let's call it a variable for now. Let me call it a variable. Okay, so we go into pandas, which will allow us to read the CSV file. So we just say read, and the read options that pandas give me pops up. Good. I've got access to read from Excel data. I can read from things like HTML. I can read JSON files. I can read various formats, XML, but we are interested in the CSV. So we read in the CSV file, and that CSV file is found in our data directory. So again, I'll press Shift Enter, and it screamed at me. So let me see where we went wrong. No such file as ice cream.csv. So where is my
Ice cream data?
What is it screaming about? So anybody spotting something I'm not spotting? Huh, that's what I think somebody spotted it, but they didn't repeat when I heard someone say. Yep, whoever voiced it out, you deserve a chocolate. If it's either Kweko or Kwabna, I just give you cash. Oh, that's the recording. Okay, good. Let's continue from there. So it didn't scream at me after fixing it. I think it was I put ice cream instead of ice cream data.csv. So pretty much that's what we did to get the data and link it to pandas, and we are happy up to this point. Is that a yes?
Yes.
I see a really good nod. That makes me a happy person as well. So we're going to try two things in terms of when we are actually viewing the data from the head. So we go into ice cream head, and thanks to pandas, we can do this without the parentheses. So without the parentheses, we get to see the whole data. So Shift Enter, and it shows us the whole data set with, of course, some of the stuff that gives us more information about it, number of rows we've got. So I'm going to do exactly the same, but with the parentheses as well, expecting argument, and we should expect the first 5 elements printed out for us. So in this particular case, we get the first 5 elements being printed out for us. And we did say that we can force it to print out maybe 150 or first 200. Let's go for first 200, and I'll press fish and enter, and it prints out the first 200 from 0 to 999. And we said you can do the same for the tail as well, which is the last set of elements. So I do tail 100. Enter. You notice it's printed from the last element. So the last set of 100 elements for us. Are you happy up to this point?
Yes.
Yeah.
Serving us just good revision, but we'll throw in some more things as we go. And with the things, you can do things like to describe the data and also to get info. But the key thing that we are interested in is that from our data, we can actually tell that we've got the temperature and we've got the revenue that we are looking at, and the temperature being an independent variable and the revenue being a dependent variable that we're dealing with. So we want to go to the next step. Step 1, we have used our libraries. We've imported the library. Step 2, we've imported the data set. What was step 3? It's always good to have a look at the data. So what was step 3? Sorry, I was I didn't visualize the data. All I had was so step 3 to visualize the data, because once you really understand the data that you're dealing with, it's a lot easier to do your analysis of the model and to tell how well your model is performing. So you can use the Z or S. UK, so I'm going to stick within it. So visualize the data set and shift enter. So let's go at this point and look. Enter there. Right. So there was a particular library that we made use of to visualize the data beautifully. What was it? Right. Seaborn. So we use Seaborn to visualize the data. So we imported our Seaborn as SNS. So we're just going into SNS. And then we made the first one we used was a joint plot. So we use joint plot, and we said, of course, we have our x-axis, and then we have our y-axis as well. And we had the actual data that we are importing. So we've got up to this point where we have we've assigned the data as ice cream, and then we have our temperature, and then we've got the revenue. So X being temperature, Y being revenue, and of course we have ice cream. So our X was equal to temperature. We need to get a spelling right, and it needs to look exactly the same as the feature label there. We've got temperature, and then we've got revenue. And we had
Michael.
Yeah, hello.
You made a typo with it's joint plot, not joint.
Spotted. Thank you. That's another chocolate good. Retro chocolates, right? So I've got ice cream. I probably fixed it. Hopefully I fixed it. There's more. And well, it's a good thing. That means you're following, right? And what did I do wrong? Error couldn't. Did I type? Oh, sorry. I'm trying to fix the typo. I made another one. So that generated the data for us and the graph for us. And I will zoom out a bit. And in terms of the simple analysis we did for this one, I think it's important because we had a few questions around this. Was just that we've got our temperature being plotted against the revenue on the y-axis, and basically what data distribution is just visualizing the data with. We have histogram showing the concentration of the data. So we've got the concentration on there and another concentration on there. So we've got concentration graph for us. So I would take it as you're happy for me to continue from here because we've got the code up to this point. Is that a yes?
Yeah.
Okay, so another graph that we had a look at was the pair plot. So I'll just go with sns.pair plot. And from here, we can just pick up the pace a little bit. And shift enter. And from the pair plot, we notice that a pair plot, basically you start with the same graph as before, which was temperature against revenue, and then we swap it to get the revenue against the temperature. And we've got a concentration graph there. So if I zoom in a bit, just I find it easier to pick this point where you have this particular point, the fourth data point there being on the bottom. Once you rotate it, then you move to the top just to show how the data has been rotated for us. So at least you can view them against each other to have interpretation of the data. And I believe we are okay up to this point. And if the other options, of course, and you can just get into Seaborn and then understand the data a bit more from there. Data visualization or various options that you can use to plot graphs. So the next step, which was step 4, so basically we visualized the data. Our next step was what? What was step 4?
Testing and training data sets.
Train the actual data. So now we're moving more to the actual machine learning. Okay, so we're going to pick up a little bit. Notice a head down. If you are tired and you want to give yourself 5 minutes, you can. Otherwise, I'm happy to continue, and probably I may throw in some new things. And if you want to give yourself 5 minutes, you can. I'll continue asking. Then I just get awake with me, then I put you to sleep through other session. Right. Okay, so what we want to do at this point, in order to create our training and testing data points, we want to take the data and split it to the X data and then the Y data set. It's just the same data set that we have, but basically we're just splitting the data at this point. So in order to split it, we will start with our Y data set. So we just say Y will go into ice cream, and we will find the revenue and assign it to Y, because that's our dependent variable. So we click enter, and we do the same with the independent variable, where we go into our X, and then we'll find our ice cream, and then we will assign it to, so we will assign the temperature. And we understand what is happening here, because basically we've got our data. We've got our X feature here. In this particular case, X is temperature. And we're mapping that temperature onto our revenue, which is our Y. We get it, which is our Y. But what we understand is that this ice cream, the number of the money we make from the ice cream can also depend on other features. So we can have several features going into our model, can also depend on other features, such as maybe the time of the day, or other things that affect why people buy ice cream at a certain peak time or something like that. So go back into the code and we say, if let's say time was part of the features of the data set, then we will import time, or we include time at this point. But in this particular case, we have only one feature. So we use the double brace. That's why we need this. Otherwise, we get an error. So again, shift enter. And we said we can visualize our Y, or we can see the content of X. And I think this should serve as a good revision up to this point so far. So we know we have 500 rows, and we've got maybe in one column format. So we split our data into X and Y. Then there was a particular library that allowed us to split the data and prepare our data into testing and then training data set. Do we remember what library it was?
SQLN.
It has another name that we used to Google for it. I believe I've opened it somewhere. So sklearn was what? If you want to find it in Google or find it online, it was Scikit-learn. I can Google. How's the whole word? So on Scikit-learn, you've got access to some regression modules, clustering modules, and other things. So really good resource for you to familiarize with. So if you have a bit of time, again, go there and do some reading. So good. We are going to go into Scikit-learn. So from Scikit-learn, so from sklearn, we want to find the model. And from the model selection, we want to import regression. We want to import the training and test data split. And I'll shift enter. And I will pause and double check. Are we okay up to this point?
Good.
It should sorry, was that something else?
Yeah, I have a question. I realized that while training the data, we splitted it. Is there a reason why it's like into revenue and temperature to train it?
Yeah, okay. So we come in, you mean before we got to this point, before we imported the train test split, we also split the data into revenue and temperature. Is that correct?
Yeah.
Okay, good. So I think your question feed us very well into what we are about to look at anyway. So I'll attempt to answer your question whilst we go.
Okay.
All right.
Okay, sure.
So I'm not very well versed with this particular whiteboard tool. It's just a random whiteboard tool I've picked up. So in case it messes up, I do apologize in advance, but hopefully it'll be all right. So basically we've got, when we started, we've got the X and then Y. So we've got the X being mapped to the Y scattered around for us. We are interested in drawing line of best fit, which will be our trained model. Right. So we've reached the point where we want to play with the actual data. Okay. And our goal at this point is to create the model. So we start off the model as a black box. So that would be whatever will be sitting in here at the end of the day. And we want to feed it with certain inputs, and then we will get a certain output. Right. So that output will be just basically the inputs will come in, and the inputs will be our independent and dependent variables. So the input comes in, which is a set of data that we call the training data set. So we put our training data set, let me call it TR because it's easy for me. We put our training data set into the model, and we'll try to learn from the patterns to create our prediction for us. And then when we finish, we're going to put our test data set in there. So that's going to be our test in there. And we said earlier, it's really important that the training set does not, the model does not see the test data set when we are doing the training. And up to this point, and also reflecting on the question that we just had, we've taken this whole data that is scattered around to initially split it into X and Y, where we can easily get access to our independent variable that starts from, let's say, 0 to the n-1 data. And again, we've done the same with our Y that starts from 0 to maybe n-1 data. We're just taking the data, splitting it apart so we can deal with it more. And scikit-learn actually give us access to a library or a function that can actually take this data and then split it into the training set and the test set for us. That is why we went through the first step of separating the X from the Y. Does that make sense?
Yeah.
That to import into the library. So we have this particular data that we've split so far, and we want to go back into the data. And well, we can still work with that. Definitely know what I intended to do, but we still work with that anyway. I just wanted this. So we want to take the data, and then we split it to our training set, X training set, and the Y training set. Basically, look at this set of input and this set of output and find the pattern. So we've got our X training set, and then maybe our Y training set going into, I should have just training XY, but make life easy for myself. And then we feed that into the model and we'll try to find a pattern. When we finish, we take the remainder, which will be the test. And then we can have our X and Y testing set. Are we okay up to this point? There's silence. Should I wait for it to sink in, or are we okay up to this point?
Okay.
So now we say we're interested in X training data set. And again, we want our X test data set. And we want our Y training data set and our Y test data set. And we will take this particular feature from scikit-learn, which is train, test, split. And taking it from the question, we already created our X, and then we created our Y. Hopefully I get the labeling right. It was small or caps, I'm not sure. And what we get to do in terms of, at this point, we get to choose whether we want the intercept to be created for us or not, or what our test size is, sorry. So we choose the test size or training size. So we just choose the test size. And we mentioned earlier from the lessons that a training size of about 75% or 70 to 75% is reasonable. And hence the test size should be about 25 or 20 to 30%. So we choose our test size of 25%. So it will be 0.25 and I'll press shift enter. So all we've done so far is to split our data into the training data set and the test data set. And the next step will be to train our model itself. I'll go to step 5. Which was to train the model. Can we pause at this point? I'll take questions if there were, and we will give ourselves 5 minutes, quick 5 minutes comfort break, and then we come back to continue. Sorry, I see a hand up. Is that a question or?
Question.
Yes, please go ahead. We're not taking the break now. Ask your question, we will address it. I'll pause the recording. So we've got the X training set. You can do the same shape to find out how many, which is about 75% where you have the data was 500 rows. So you can do the same to test your XY training and see how many were created for you. But we want to do the actual, make use of actual linear regression to do our testing. So we go into scikit-learn now. So we're going to from sklearn. And we want to find our linear.
Michael.
Yes, please. I'm not sharing my screen, am I? Sorry, what was it?
No, can you please talk louder? I can't really hear you.
Oh, okay. This is a voice test for me now. Wait 1 second. Can you hear me now?
Yeah.
More coffee. Okay, good. That's a good thing. Thanks for pausing me. So basically, we just had a look at the shape of X. You can do the same for Y and others, especially if you type in alongside with me, or later on when you go home, you can do that as well. So we just want to go into sklearn and then find our linear module to import. And of course, you know how to learn more about scikit-learn. So we're going to linear model and then we want to import the linear regression. Hopefully it won't scream at us. Oh, good, it's found it. So it's not going to scream at us. No errors. We can continue. So now that we have imported our linear regression, we want to actually go ahead to assign this to a model. So let's find a model and call the name model name regression, right? Or regressor, whichever you choose, which is just like a variable name. And we assign a linear regression. And from the linear regression, we want to fit, we get the option to choose whether we want to fit the intercept or not. And the intercept is the B, remember? So we've got this particular graph there. Hopefully I can zoom onto it. At least I can do this to make it clearer. So you've got our X and then we've got our Y. And remember, Y is equal to B plus MX, where M is the slope or the angle of slope, and then B is the intercept, right? So where we're starting from. So if B were to be 10, we probably start from somewhere there with the same slope, the graph will look like that. If B is 0, it will go that way. Or if M were 0, the graph will look like that. So basically, we get a choice to say whether we want it to fit the intercept, which is B, or not. So we started off by saying the intercept should not be fitted, so we chose false. And I'll execute that, and that's okay for us. So the shift enter to the next one. And we want to find, now we want to actually train the model. So we just say regressor. And from the regressor, which is the variable, the one we just created, we say fit our X training with our Y training. I believe it meant both. Okay. So basically, we just, at this point, simply feeding the training data set into it. Shift enter. Good, it's actually done some fitting for us with the intercept being false. So at this point, we want to see the model see the model that's been created for us. We can get access to the B, and then we can also get access to the M, which is the unknown variable. So let's try to see whether it's created for us based on the training data set, right? So we just say print. And from the print, we can just make it more meaningful. So linear model coefficient M. And from that, if we go into our regressor, which is our model, and we want to find the coefficient. Same thing, we can do that. So we get the M and we can go for the B as well. And the B was the intercept. And that's picked up as well. So hopefully it will scream at us when we press shift enter. Scroll up for us. So we notice that it's created a model for us. So with the slope being around 23, and the B or the intercept being around 0. So we're going to have a graph that looks like the one in red, starting from B and upwards, but starting from 0 and going upwards. Now we can tell our model to try to also fit the intercept for us. So try to predict the value of B. So to do that, we set it to true. And we need to, again, run this. So we just run the regressor again, and we can fit. And then now we can print. And we notice that the value of E now has been changed to 45. So it's actually moved the graph to something like this one for us, with the B starting value being 45. I believe we are okay up to this point. I see a hand up. Sorry, I have to move as you asked the question. and you will tell me your name. Hopefully it's not the same name I learned. You tell me your name and then I'll try to learn your name quick.
My name is Chuda.
Judah. Hi, Judah.
Chuda.
Judah.
Yeah, hi, Mike.
Is it
No,
Judah?
no, Chuda.
Judah, sorry. Okay, go ahead, Judah. Sorry. I do apologize.
Oh, never mind. No worries. Okay, so I wanted to ask on Friday, the intercept we got is different from the one we are just getting right now. Why is that so?
Yeah, so basically you've got this training that you just given it. So the model just trains it, and like remember when we talked about the black box system. So you've got data you're feeding into the system. It will try to fit based on the training that you're giving it, but it will give you some level of confidence in terms of a 70% sure that the model is created actually is the best line of best fit. It can also give you some level that maybe 70, 80% sure, 90% sure. So it will just try as many times to give you the right line of best fit in there. And unless maybe I tweak the data slightly, then yeah, it's just basically learning the patterns from the model. But you realize that it's quite close to each other, not too far off.
Yeah. Okay. So does the number of times you call regressor.fit on the X train and Y train, that the number of times you do that, does it improve the accuracy or something?
Well, normally what people would do is people will rather adjust the amount of training data sets. So instead of just the same thing all the time, instead of using about, maybe you start off with about 70-30 split, and then you can increase it. And actually in this week's theory session, we're going to talk about tools that we use to evaluate the performance for you to see as well.
Oh, okay. Thank you very much.
You can just go back and forth and run it. I was just going to do that, but there's no need to do that. To run it again for you to see, but it shouldn't come up with something different. It's just that we're using an online tool anyway. Yeah.
Yeah.
Peter, thanks for the question if it is answered, and nice to get to know your name as well.
Thank you very much.
I'll wait for you to take your seat and we will continue from there. Okay, so basically we are happy up to this point, unless there's another question. I don't see a hand up or anybody screaming at me, so I'll just take it as you're happy to continue from this point. And our next step was to do what? We've basically trained the model. What do we do next? Who wants chocolate? After training the model, what do you do? You test the model. Thank you very much. Who was that? Let's find a way to actually give you the chocolate. So then shift enter, we want to actually test the data, right? There are other test tools, but earlier on I used, like in the previous class, I used validation score, but I'm going to skip that now because it was just creating a bit of uncertainty on the side of people, and people weren't quite sure what was happening. So let's go into actual prediction for us now. Sorry, I had someone say something. You happy for me to, is that a question? Nope, everybody's quiet. So we're going to go into our prediction. So we create our Y predict, which is the Y. And from how we're going to get a predicted data, we just go back to our regressor, that's the model that we created. And we want to tell it to predict based on our X test data, right? So we feed it with our test data. So we take our model, feed it to the test data, and pass the results to Y predict. So hopefully I typed everything as I should, and I just press Shift Enter. It's not screaming at me yet, so it means that probably things are on track, and I can see whether actually predicted some value for some data for me based on the X. So it's a Y predict, shift, and great. When you have a bit of time, you can take the actual CSV file, which is the actual data set that you have, and you can pick points around these areas to see whether they actually exist on the graph. So basically, all we've done at this point is just now feed in our test data to see whether for each test data point, we generated a Y value. What you will find at this point is that if the actual data points, let me draw another one, because I just double click on it. So if we've got the original looking something like that with a data set there, and the model that was generated for us look something like this. Let me pick a data set that is closer than this one that is too far away. And we have a data set, a data point there. So let's say this data point is actually, I don't know, 97. When you cross-check with the actual model that was generated or the predicted values, you may find out that maybe if the value for X that generated 97 from the original data was maybe 5, some random thing. From the prediction, you may get something that is close, maybe 96 or something like that. So not exact, but based on the level of confidence that you created. Good. Can I continue from this point? Are we okay up to this point?
Yes.
So we get to play with, sorry, was that a question?
Please, I have a question.
Yeah. I got 2 questions. Can I have the first person who talked to tell me the name, because I think that person is closer to the microphone, the name, and then the question.
I'm Abigail, and
Go. Is it Abigail?
yes, or you can just say Abby.
Hi, Abigail.
Oh my God. So, yeah, so what exactly is it predicting? Is it predicting how close it is from the line of birth rate, or like, I don't understand.
Okay. So if we come, let me do this to make life easy for us. Hopefully it's clear the screen and we can. So we understand that the original data that we fed into the system looks like this because we visualized it, right?
Yeah.
It got something like that. And what we have done is actually try to use machine learning to find the line of best fit, right? And it started from 40 something and created this for us. Yeah?
Yeah.
Now, this line of best fit is actually the model that we have created. So it simply shows that it's the line that is closest to all these data points. So if I have maybe the data set does not continue up to this point. If I've got a value maybe 500 because we start with 575, for example, looking at the pattern, looking at the way the data is distributed, if we want to predict, find the value, or if we have a temperature of, which probably unrealistic, 575, how much money would we be making? Does that make sense now?
Yeah.
Okay, we understand up to this point. So if we have this particular temperature, make it realistic, about 100 degrees, right? So data point 575. How much money would we be making? Basically, we just map it to our model. And then that will reflect the Y value there for us, with some error, of course. So the Y value at this point may actually be, I don't know, £1,000. To say if it's 100 degrees, we are likely to make £1,000. You understand up to that point?
Yeah.
Okay. Now, if I go back with what I was trying to explain earlier, so for this particular data point, this is the actual data that we got from the data set. So if this data point is for a temperature of maybe 30 degrees, the actual money we were making at 30 degrees was maybe I don't know, 50 pounds, right? So let's say, yeah, 50 pounds. We're making 50 pounds when the temperature was 30 degrees. Now this machine, if we feed that same 30 degrees into a machine learning model, now the model has moved away from the actual data point. So we are likely to map that 30 degrees to hit somewhere around 49 pounds. So from the model will tell us that we've been making about 49 pounds, which is not too far off from the 50 pounds. But what we have created is a way of predicting based on the current temperature, how much money we've been making, because it sort of has a linear distribution.
Okay, makes sense. And also, you see, we can specify whether we want to make the y-intercept start from 0 or like a constant, right? Doesn't that affect the line of best fit? Like, if I put if I set the line of best the b to 0, and someone else sets.
Let's see, it doesn't affect. I think a beautiful thing you would do, just because mine is sitting in my Google Drive. Beautiful thing you can do from your side. The slope is obviously going to be the same. Is to actually go back to look at each data point. I mean, I was moving further to show you how to view each data point that's created. So go back to each data point and compare the actual X estimated value with what is coming out when the line of best fit, when the B is 0, and then also when you set this to true. Does that make sense? It would be a good thing for you to find out from your side as well.
Okay.
Yeah? You get to see it. I think coding, we get to see the output directly and then play with it. So it's best you play with that to see as well. I had another question. Do we want to pick that other question if Abby is happy?
Yes.
That's how says Abby is happy. So sorry, the other person who asked the question, can you ask your question now, or who wanted to ask?
You have to come forward.
The first time you came here.
Joseph, was the name Joseph, was it?
Yeah, Sir Michael, Joseph here.
Is that Joe?
Yeah.
All right.
So, I mean, I want to know the same question as Abigail asked. I want to understand the output of the result we got using the Y predict, or the prediction function. Because, the values I'm getting there, I was thinking that we're going to get pairs. You get Y and then, you get Y and then X. But like everything we got it in terms of the revenue. The temperature values didn't show. So I wanted to know, I wanted you to explain it to me.
Why is Y
predict? So I believe that part of the question that was quite similar to Abby's question is answered. Is that correct?
Yes, please.
So remember, what we are interested in is to find how much money we see. That we don't know, but we know how to measure what? The temperature.
You're so known everywhere.
Yeah?
Yes.
So the Y is the unknown. We are interested in our money, right? But the temperature we can measure. And we notice from the data we've collected over time is that it's a linear relationship. So the other things that we don't know is the B and then the M, which is the intercept and the slope, right?
Yes.
So this B and M is what is going to sit in our model. After we train the model, our model is basically the B and M. So if X is 20 and the model says the M is, in our case, I think it was 22, it's just going to multiply that, and then it's going to start off, maybe if this was when it was 0 or when it's 45, it's going to affect it. And actually, I didn't want to answer that part of Abby's question, but right. So basically, it will affect the value of Y that is being predicted to give us the Y value, because all our model is trying to predict for us is our money. That is why we are getting only the Y. Does that make sense?
Okay.
Is that helpful?
Yes, I mean it's helpful, but I was expecting the values to be in pairs so that we know that this X value that give us
Okay. Yes, we have that in terms of the actual data generator for us. Yes, we can visualize that, and that's the next couple of steps that we are about to go through.
Okay.
So
Thanks.
hopefully I'll answer your question within 10 minutes, right? I'll try not to go too fast, but let's see how it goes. Can I assume there's no other question? Is there any other question, or are you happy for me to continue?
Please continue.
Okay, good. Thank you so much. So if I say we just want to, again, you can visualize the shape in terms of your predicted data set, how many you have. So if we take the Y predict and we look at the shape, same time, we can view the shape of other things in terms of the size, in terms of the test data. And I think I'm beginning to lose my voice by screen. Right. I believe this was caps. And the same, we can do the same for the X test and other things. But that's not our main interest at this particular point in time, just to show you that you can try this later on in your own spare time. And we notice that the predicted, the size of the predicted Y data is quite similar to that of the test data. And of course, it's the split shows quite well. So we've got the X and then the Y mapping onto each other. So that's good news for us. You can do the same for the temperature and other things. But following on from Joe's question, we want to do some really quick visualizations, hopefully in a really short time. So we make use of scatter from Matplot, right? So we just go to plot and we want to plot our scatter diagram. So we take a scatter, and from there we want to get our training data set on the x-axis. So train, x-train, and we're going to go to y-train. And at the same time, the printing, we want the color. I did a test to see whether different spelling will work, and they did work. So the color, we can have gray with G-R-E-Y or G-R-A-Y. And hopefully wouldn't complain or wouldn't scream at us. Yes, and this is just the training, not the test results. So we're going to have that, and we'll do the same for the test as well. I'm sorry if it's a bit too fast, just let me know. I'll slow down, rather slow down. So I do the same, just the same line of code, and I'm doing for the test as well. And you can try gray with G-R-E-Y to see if it works, and both works for us. The only thing we notice now is that it's given its strange title for both of them from Matplot. So we want to label our graph in a nice way that we can use. So we're going to start off with title. So let's set the title of the plot. We are close to finishing anyway. Hopefully we'll be on time. So we just say revenue generated versus temperature at the ice cream data. We've got our ice cream stand, and we want to use the training one. So if I press Shift Enter, we notice that it's giving it the right title that we want to use as well. And I want to copy this and do the same for the test data. So I do the same for the test data set, and I've got a really nice heading there for myself. And I'm going to try to label the axis, so we can go to the plot y-axis. So the label of the y-axis, and I'll call that revenue. And that can be in dollars if you want to put dollars there. Or well, the question said dollars, but problem said dollars, but I can make it whatever way. Then we want to do the x-axis, the x label. And that one we will call it temperature. And we'll have it in degrees Celsius. So degrees Celsius. So I'll press Shift Enter and hopefully it will label for us without screaming. And we've got a nice labeled graph or beautifully laid out graph that we can use. And I'll do the same for the test data set as well. And press Shift. Now, what we want to do is to predict and overlay our line of best fit. So if I just go into the plot and I just want to plot a scatter, that would take regression line, that would take the X training data set, and we'll pass that to, on the other side, we'll have our regressor. And from our regressor, we want to do our prediction. So we predict, and what we want to predict from is the training data set. So we take our training data and we will set the color of that to red. So basically just taking our training data and then we just do some prediction on that and to get our line. So we just shift and run. So that shows us the model overlaid on there in terms of what we've been trying to do. And of course, there are a few data points that lie slightly outside it, but pretty much the prediction will be quite close. Probably this will be the most offset when we have a look a proper look at the actual data. So we're going to do something similar with the test data again. And overlay onto the test. I did for the training for the test. So let me just put the train and run that. And I'm going to do for the test as well. For the training, you can see title there and test. So we've got a test on there, and the data we are importing on there is also the test data set to work properly. And that should give us a better output because I did mistake earlier. Can I double check whether you are okay up to this point?
Yeah.
Yeah. And Joe, can I double check whether this helps to address your concern you raised earlier?
Yes, please.
Okay. I think I've already shared a version of the code. Ekweku and Kwabna will be sharing a version of the code with the whole class. I'll pause the recording here and give room for, I don't know, briefly, a lot of questions. If people have questions for me, or otherwise, we'll bring the session to a close about 2 minutes earlier. So we've got 1 minute to still talk.